back to part 2 of the volcanic lecture. Here is a sample image of various types of volcanoes. The only ones we really need to talk about are fissure volcanoes, cinder cones, shield volcanoes, composite volcanoes. These two over here, we don't want to talk about them too much. The bad thing about this drawing is that these are way off scale. This, 1,500 feet high, normal. Here, 10,000 feet high. In the case of a shield volcano, up to 30,000 feet high. This can be well over 100 miles across, 20 miles across, less than a mile across. They all look the same size here, so this is unfair. Here's a picture from your book. The entire Big Island, Hawaii, contains Mauna Loa, Mauna Kea, Kilauea, Hualalai, all kinds of volcanoes that form a shield volcano. Now, notice the artist here made it even steeper than the real island is. You hire artists to do this kind of stuff, they don't get it right. Shield volcanoes are really shaped like a shield. You have hot material coming up, it flows really easily, it's not explosive, so you just get like a bunch of pancake batter poured on top here. Not quite as pancake battery as the volcanoes on Venus, but close. Even on the side of a shield volcano, you can have what's called a cinder cone. Here's a cinder cone on the side of Hualalai, which is the volcano up here on the Big Island of Hawaii. In this case, a vent is just shooting out basaltic material. It goes into the air and comes back down solidified. Here is SP crater in Arizona. It shot up stuff that landed back down, and it also had from the base of it a basalt lava flow, which is and it is hard to walk across, even a few thousand years later. Here's a typical cinder cone, the steepest form of volcano, but again, the smallest form of volcano. These can occur fairly quickly. In the case of the one in Arizona, Sunset Crater, 1064 and 1065, when William the Conqueror was about to do his stuff, we were getting an eruption over in Arizona that was affecting the Anasazi living north of what would eventually become Flagstaff. Here is a child's drawing of a cinder cone. Again, notice the difference. Now, composite volcanoes. When you have subduction zones, you get composite volcanoes. And these guys can be dangerous. Plumes of ash that can go 40,000 feet into the air. In the case of some of the volcanoes in Alaska, jets, not knowing at the time, flew through some of the ash, froze their engines up, plummeted toward the ocean, getting their engines started, I think, less than 10,000. I want to say less than 5,000 feet from the ocean's surface. So there's now a warning system to avoid this kind of stuff. Notice the flows going down from this volcano. These guys are destructive. They let out lots of pyroclastic material, lots of ash. Here's Pinatubo in the Philippines in the 1980s, which led to the Americans shutting down the Clark Air Force Base. Now, when you have a volcano like this, and the stuff underneath it goes away, it collapses into what's called a caldera, kind of like a cauldron, like a witch's brew keg type thing. Here is the magma storage chamber. When the pressure is withdrawn, the top of the volcano collapses. You get steam explosions, and then you're left behind with a crater which sometimes fills with water. And if you get a subsequent eruption, you get this. Let me switch to the web page and reload this. Underneath here is a balloon that's going to be blown up with air, simulating the stock or the magma storage chamber. It's going to erupt, and then the pressure is going to go away. Eruption, loss of pressure, and the collapse into a caldera. Very cool. It really does happen. Here's what happened after this volcano erupted in the distance. Here's the caldera left behind. Now, a lot of times, sulfuric dioxide and hydrochloric acid bubbling up through the water will make these extremely acidic lakes. You don't want to go in them. Animals that try and drink out of them, they can die. Can you farm down here? Well, there'd be great soil. The air can be really bad, though. Here's Crater Lake in Oregon. The volcano used to go way up here. It has since sunk way back down, and a subsequent eruption left little teeny Wizard Island out here. You can go out and take a boat to this. I don't know if you can climb up it or not. Volcanism in Arizona. By the way, the old word is volcanism, not volcanism, so you'll see it both ways, volcanoes and volcanism, not to be confused with Mr. Spock. All around San Francisco Peaks, Flagstaff, are volcanic remnants. All these little mountains are old cinder cones or composite craters. Sunset Crater, right over here, a cinder cone. Here's the old visitor center. This is from the 50s or 60s. You used to be able to go up it. They have since abandoned that, I believe, and you have to go up another crater nearby called Lennox Crater because this one was eroding so much. Again, this erupted last in 1064, 1065. As a child growing up over in this direction in Winslow, I always wanted to go up to the rim and look down into the earth and see the boiling magma. I was so disappointed when I got to the top, and there were pine trees down in here and it was cold. Oh well. There's Sunset Crater again, and you can see the lapilli, or the cinders. We mine these in northern Arizona and use this to make the roads out of. Probably not good because they're so porous when water gets into the cinders crack and the road ends up with potholes. Here's what the cinders look like up close. They do come out really black, but with the iron in there, they oxidize over time. Here's Thunderbird and 7th Street in Phoenix. This mountain right here, it's volcanic. Go look at it. That's all basalt. If you ever park in the little parking lot right down here at North Mountain and then go hiking, it's on the north side of the trail. It's just on the south side of what I think is the AJ's right here. Here's a picture of that mountain from right over in here. North of the 101, over by 59th Avenue, these mountains are all volcanic. The mountains right along I-17 by Deer Valley, north of Deer Valley, volcanic. And, something your book doesn't talk about, when the lava roof's over, sometimes the top will cool and the molten stuff underneath keeps flowing through. That's your crazy science teacher standing on top of a lava tube or a skylight. The lava is flowing underneath me and down to the ocean in the distance. This is a lava tube in Arizona up in the Flagstaff area. Out, somewhere in this area out here, there's an old lava tube. And people have broken off everything inside, but there it is. Now, there is lava on the moon. These are all basaltic flows. Notice the front side of the moon has a lot more basalt than the back side of the moon. The basalts on the moon are extremely old, so it is solidified a long time ago, and there are no tectonics going on anymore. Mars. This is crazy. Olympus Mons, biggest volcano in the solar system. 85,000 feet high, 370 miles across, bigger than the state of Arizona, this one volcano. How can it be there so long? There are no plates moving, so when something erupts, it just keeps erupting. Here is Mount Everest. Here is the Big Island, Hawaii, going up to Mauna Kea and then back down. Here is just the caldera of Olympus Mons by comparison, and then it goes way out on either side. It's huge. On Venus, it is the most volcanic planet in the solar system, 1,600 active volcanoes. This is all volcanic basaltic stuff. And I think each of these craters is about 40 miles across, or these calderas is 40 miles across. Something else I wanted to tell you. Oh, very thin lava, so it doesn't pile up into the steeper mountains that we see on Earth. They tend to be a little bit more flat. If you see really steep images on Venus, there's usually vertical magnification going on, or exaggeration. Oh, run that again. Here is an eruption on Io, one of the Jovian or Jupiter satellites. Jupiter pulls on Io so hard it creates all kinds of distortion, and here's a little volcano that results from that. And this is the end. This is a lava flow on Mars, and here is an elephant. Whoa, weird. Thanks for watching.